Hello, everybody. Today, we are doing part 4 of reverse list by pod. The reason why we have a part 4 is because we discovered that we could improve the space complexity by solely using the linked list rather than using a array to separate out all the heads. We could just simply get each pod and separate those out properly and then join them together one at a time. So let's think about how that's done. So this is going to be another function, a brand new function. We're just going to start down here instead, because if we don't want to mess with a function that already works. As you can see, all the tests are passing. So this time what we're going to do is save space, and we're going to basically do the same thing. Okay, so we have to create another plan again. We're making a new function. We're making basically creating new tests. It should do exactly the same as this particular test, right? Everything should work exactly the same as reverse list by pod, but save space. Okay, that's the difference. It's save space. So here we go. Let's just change all of these. So all of these tests should pass exactly the same. Okay, what's the plan? The plan is we grab these items like so. And where are we? All the way down here. So this has gone pretty long. So what we're going to do is create a previous pod and a next pod. So these pods are disconnected, like we have done in our array. So we have previous pod, we have the current pod, and we have the next pod, right? So what we can do is just reverse the current pod. So let me write that down. Create 3 pods based on length of k. Okay, so previous pod, current pod, and next pod. All right, so how do we create it? Well, just like use get next pod function by reducing k to 0 and return next pod. So we're going to get the next pod by starting at the current pod and moving k moves. So 1, 2, 3 moves. We will get next pod. Okay, so with the next pod, we can disconnect this connection between 3 and 4. So disconnect current pod from next pod, and we're going to reuse a reverse list function. Reuse it's been tested, so it's good. It's a good function. Our reverse list function. If we've produced any new function at this point in time, that means we have to test that new function as well, and that's not fun. So let's not do that. Okay, so here we have, let's reuse the reverse function. So we reuse the reverse function, and then we have the points to, now we're going to point it to we're going to have it to 723. So we're reversing this portion right now using the reverse function. So everything's reversed in this item, and because we use the current pointer and use the reverse list, we have a head pointer here and tail pointer here. With that, we can point the previous pod, point previous pod to head, and point head.prev to previous pod. So this way we can join these pods together. Okay, after that, let's move the previous pod to tail. So now previous pod is going to be at tail, and current pod is going to next pod. So current pod is now next pod. So next pod is here. So this becomes current pod. Of course, remember we severed this connection here. And now we basically, right? We basically have the same same problem as before. Let me show you why. So because we have severed the connection, it's the same as the previous one, as the dummy node. So our current pod is here. And we also go 3 spaces, 1, 2, 3, and get the next pod, and so on and so forth. And then that means we sever this connection again, and we reverse these items, right? So we make a reverse, so we have 6, 5, 4. We make a connection between the previous pod and the head. So this is now head and tail, right? Remember? And so this means we can connect these together. And this also means we can move the previous pod to the tail, the next pod, the current pod to our next pod, and next pod is going to be now at none because it's a none item after 8. So with that, we also do a reverse on the 7 and 8, and we do a connection between the two. And now we have basically solve the problem. We can now do this without using extra space like an array. So what the last thing to do while current pod is not none, right? Because once with this we finish up. So while current pod is not none. And once that happens, we can do a disconnection. We could disconnect. Let's disconnect dummy node from our what do you call this thing? We could just return, but that would cause a problem because our head node is pointing to our dummy node. So remove dummy node from our linked list and return dummy node dot next as head. So we have to set dummy node as head first to return it. So before we disconnect. So we set it, we disconnect it, and we're good to go, right? Oh, looks like we copied the wrong thing. Well, head equals dummy node dot next. And then we disconnect it, and let's return head. And that's it. That's our function. So let's comment all of this out. Each of these lines, we don't need that anymore. We went over the function, and we were able to solve it. And with this plan that we have, we can go along with implementation. So first things first, let's read. We need to create several pods. Well, first things first, let's create the dummy node to create the dummy pod. I mean the previous pod. Dummy node is equal to linked list at node at, let's say, a head. It makes it easier for us. Then it's not connected or anything, but we're going to set previous pod to be equal to dummy node. The current pod is going to be set to our head, and we're going to move everything forward. And while current pod will, as long as it's not none, we're going to get the next pod. Next pod is equal to our next pod function, get next pod. And we're going to get the next pod from our node and k. Okay, So let's create that function, make a few tests, and make sure it works. So get next pod. We're gonna create a head list linked list node, and we're gonna get k an int, and we're gonna return a linked list node. So what's gonna happen is while k and head, let's call this node. I think that's a better word for it. Node equals node dot next, and k minus equals 1. Return node. That's it. So that's our get next pod. What we believe this get next pod should how it should function is we should be able to get the next couple of pods. Let's run this function using just this. So get next pod. So next pod should be 3 because we are moving 3 items. And well, if we move it by, let's say, by like 5, we should get 5. By 1, we should get 1. So it should be pretty good. Let's comment this out, because actually by placing these items into the test, what we're doing is running the function and generating the output, which we can present a little bit later. Let's run it. So it's false. Uh-oh, that's not good. What happened? That means we're not returning the right node. Okay. So let's print out the node that what's going on. So we're printing 4, 5, and 6, and 7, and 8, and 6, 7, and 8. So we were predicting a 3 and a 5. I think that was the wrong prediction. We made the wrong prediction. So that's fine. So we were thinking 6 probably. And then that would be 7. So this would be as we predicted here. So let's check it out. Let's run it. And it has passed perfect. And that's exactly what we wanted for our test. So with that, do we have any edge cases that we want to test maybe? Like -1 for k. Let's see what happens. So it looks like we're making more functions as we go along. But these functions, these tests, should be more helpful. So what happens if we receive a -1 is that we're going to just return node 1 basically. That's my prediction, and it returns none actually. So what's up with that? Should we return none? Is that the case? Because I mean, there should be no next pod if we have a -1. I think that's about right. That should be right. So if it's 0, then what happens? So -1, why exactly it went all the way to the end and returned nothing and gave us no pods. The reason is that basically it went below k went below 0, and it just doesn't matter. When when k is 0, that's when this occurs. So when k is never 0, then it just keeps on going forever. So it's impossible to get -1 pods. I think that's a good idea. Why not? There's no next pod when you're asking for a next -1 pod. And there is no next pod when you're asking for a next pod of 0. What you get is, well, of 0 size is that you get a single 1, and you get the current node. Do you think that's right? I don't think so. So if k is less than or equal to 0, let's just return none. I think that's the proper output to save this function. So that's what we want. So let's set that to none. And we make sure that anything less than 0 will return none. Perfect. With that, I think we have completed the edge cases for get next pod. And we can now return to our reverse list pod safe space function. So here we go. Let's see. We're going to get the next pod, reduce k to 0, then get the next pod, disconnect the pod. Okay, let's disconnect the pod then. So as you can see how great this plan is, because by going to another pod, writing some code, we have already forgotten where we were at, and with this plan here, we still remember, which is great. Right. So if next pod, then next pod dot prev equals none, and next pod dot prev dot next is equal to none. Okay, so we have disconnected the next pod, and what happens next? So while loop. So while current pod is not end, I think this goes here instead. We set this up a little bit too early. Okay, little bit too early. We're gonna reverse our current pod. So head tails equals reverse list of current pod. So we get our head and tails. And then we can point the previous pod. Previous pod dot next is equal to the head. Head dot prev is equal to previous pod. And we're going to move our previous pod to our tail, and our current pod to the next pod. With that, we have completed the current pod function, and head is now equal to dummy node dot next. So we'll get our first item. And let's disconnect our dummy node. So dummy node dot next is equal to none, and head dot prev is equal to none. So with that, we are good to go. Let's return a head node as we predicted, and let's run these. Let's run some of these tests to see where we're going. Make sure that we're a-okay, that some of these functions work, and whether it does or not does not. So we have an issue. So let's check it out. 189. 189. So get next pod. What's the problem? Output 3. Node is not defined. Right, my bad. Current pod. Okay, everything passed. Perfect. That means let's run the rest of this code. I think there might be an issue with the -1 at this point. And yes, I was right. So -1, we should return none. So let's make sure that's the case. This is something that we did not do, did not check for. So if k is equal to -1, return none. Let's run that. Oh, my bad. Let's run that. And good, we have passed all the tests. We basically, with this, we have done the review. And let's evaluate this code. So the evaluation is that we kind of basically traded time for space. So the amount of space that was required, basically, well, I don't think we traded time for space. We used the same amount of time because we had to get the next pods anyways. It was the same. So I think we saved time and space actually. So because we don't have to go through it twice. So, but what I mean by twice is that we had to get the next pods and then we had to reverse each pod. Let me show you the code earlier. This was our previous code. Remember how we had to do 2 for loops? Yeah, exactly. We had to get the heads first and then reverse each head and then point them to each other inside the array. With this, we point them directly without the array. I think this code might be cleaner, but this code is definitely shorter, I think. So let's get the evaluation then. Evaluate. Well, it's still going to be O of n time because we go through every node. And it's going to be O of 1 space because we didn't have to. We only used pointers, and that's it. That's all this problem is. I really hope you enjoyed this video. If you learned something and that you learned something today. If you enjoyed the video, like and subscribe, and I will see you in the next one.